NOR gate, right? NOR based SR latch we discussed, right? So no. After that, so we implemented same NOR based SR latch. Same NOR based SR latch what we did, we implemented in the NAND. So no. So the same NOR based SR latch we implemented in the NAND, and we got okay. So we conclude that okay. So we can implement the same okay truth table by using NAND as well. By using NAND as well. When we are same replication output we are implementing, how it comes? So no. So this circuit in NAND representation we implemented like this. So after that, okay, so we went to D latch. Okay. After that, we went to JK and T latch. So if you observe this, all the latches will store single bit data. No doubt in that. So now, so I already told one more thing is okay in J why we are went to JK latch, because 1-1 condition will come. This okay invalid case. To overcome that 1-1 condition, what we went to JK latch. We went to JK latch. J will be there, K will be there. Okay, so this is the JK latch. So now, so in the JK latch, what is the main problem is, so if suppose E is 1, E equal to 1, J also 1, K also 1. Okay. So now, if memory is 0, consider memory is 0, this Q is connecting to 1, 2. So second gate, right? This one is 0, then output is 1. This Q bar is connecting to here. This is 1, this is 1, all are 1, this will be 0. 0 and 1 means it is the set case. Set case, yes or no? For this circuit, it is set case. Set case. So now set case means Q becomes 1, right? Output becomes 1. This 1 again will comes to here. So all are 1, 1, 1. This becomes 0. This Q bar goes to here. This one is 0. This becomes 1. So then Q becomes 0. So means until unless this enable is 1, keep on it will check the input combination and it will generate the output. Until unless, okay, it will check the, until unless this enable is 1, keep on check the input combination and it will generate the output. So this problem only called, okay, what we will call race around condition. Race around condition. Because of race around condition, what is the problem? The main problem is power consumption. Keep on it is checking and it is generating. Switching is happening, right? Dynamical power consumption will happen. This is one thing. And second thing, there is chance to be functional failure because of this race around condition. Clear? Unnecessarily. One time it does generate the output, it is enough. Keep on it is checking. Okay, this is the problem we will see in the latches. This race around condition problem we will see in the latches. How to resolve this race around condition? To resolve this race around condition, we will have three solutions. One is increase the propagation delay of a increase propagation delay of gates. Means this gate 1, gate 2, gate 3, gate 4, 4 gates are there, right? These all the 4 gates propagation delays we need to increase. Now see, if I will increase the propagation delays of these 4 gates, means so whatever time taken to generate the output, okay? If I will increase these gates propagation delays, so then what happened? The response time of a chip, response time of a latch will be increased. If this latch, if I will use in the design response time also increase, right? Means the speed of the design will be decreases. This is not a best solution. Now next, what is the solution for overcome the desired condition? Means master slave configuration of latches. Master and slave. Master slave configuration of latches. Master slave configuration of latches. Master slave configuration of a latches. So this is the master slave configuration of latches, means it is flip-flop only. Flip-flop. Okay, flip-flop. Third solution is edge trigger. Edge trigger means it is also flip-flop only. If suppose this is enable, right? Instead of enable, if I will give here edge triggering signal, if I will give, it will work with edge trigger. So then this will become the flip-flop, not a latch. It means no more latch, it will be flip-flop. Clear? So these are the 3 solutions. So we can obtain this solution and this solution. We will not go with the propagation delay increase. Okay. So let's see how the master slave configuration of a latches. Okay, what are the condition for master slave configuration and how we will implement these things in our flip-flops. We'll see now. Okay. Before this master slave configuration, you need to know some conditions, some rules and regulations for configuring. So rules for master slave configuration. Rules for master slave configuration. So what are the rules? First rule is if I want to make okay, JK flip-flop. Okay, master slave configuration, with master slave configuration, I want to make JK flip-flop. The master should be JK. If I want to make a D flip-flop, the master should be D. If I want to make SR flip-flop, master should be SR. If I want to make a T flip-flop, master should be T. Based on the which flip-flop you want to be build, that should be a master. Okay, note down. Based on which flip-flop you need to build. You need to build that latch will be master. Example, if I want to build JK flip-flop, my master will be JK latch. Clear? This is the first point you need to remember. Second point, always slave should be D flip-flop. Second point, note down. Always slave should be D latch. Always slave should be D latch. Always slave should be D latch. So this one is okay. So JK latch we need to be used as a master if I want to make JK flip flop, JK latch, and this one is D latch. Slave should be D latch. So now third condition. Master and slave should not be same level trigger, means it should be opposite triggering. Master and slave always should be opposite trigger level triggers. Okay, master and slave should be opposite level triggers. Master and slave should be opposite level triggers. This is the third condition. Fourth condition, if you want to make positive edge trigger, master should be negative latch, slave should be positive level trigger latch. If you want to make positive edge trigger flip flop, master should be negative level trigger latch, slave should be positive level trigger latch. So fifth point, if you want to make negative edge triggered flip flop, master should positive level trigger, slave should be negative level trigger. Simple. How you need to remember this means, see, master is negative, slave is positive. Positive edge triggered flip flop means what? Positive edge triggered flip flop means positive edge means what? With the edge which is going from 0 to 1, right? Yes or no? 0 means what? Negative level. So master will be negative level, slave will be positive level. So then it will be positive edge triggered flip flop. If master will be positive, slave will be negative, this is a negative edge triggered flip flop. That's it. Remember like this. Okay, this rememberation is very important. See, when I will study, okay, I don't know these things, so then I feel okay, what is confusion. But after when I am start teaching, then okay, if you go with this, then you easily remember, right? So that's why remember like this. Clear? So first 0 to 1 it is going. 0 means what? Negative level. 1 means what? Positive level. 0 to 1 it is going means, okay, if I want to make positive edge triggered flip flop, master will be negative level latch, slave will be positive level latch. Clear? So like that you need to remember. Now, so every time I can't represent these all the things, right? Every time I can't represent like this in the gate format, right? So what I will do, simply I will make one box. These all things inside a box. Okay, I will make, this is a J, this is a K, this is a E, this is Q bar. Okay, I can represent this one like this, right? Under D flip flop, how I can represent? D enable Q bar. Yes or no? So now we'll see JK flip flop configuration. Keep heading JK flip flop configuration. JK flip flop configuration. JK flip-flop configuration. So in this JK flip-flop, based on the condition, what I need to say? Master should be JK. Yes or no? Master should be JK. So I will draw. Okay, master is JK enable latch. Okay, master should be JK latch. This is a Q. Q bar, sometimes they want to be keep, they will keep the Q bar pin. Sometimes they don't want, okay, they will not keep. Okay, so depends on the requirement, they will kept and they will not keep. Okay, so this is Q. Clear? So now slave should be always D latch. Enable, you can write enable Q. Clear? So now if I want to make this is a positive level triggered, my master should positive level trigger. I want to make my master should be negative level. So my master should be negative level. My slave should be positive. Okay, this is negative level, positive level. Means opposite. Getting? If here we are giving 0, so then it will get 1. If we are giving 1, this will get 0. Getting? So now in the advanced representation, they will not represent with the inverters. Okay, they will remove this inverter also. So they will, what they will do? They will simply add one bubble before this enable. If this bubble is there, that is negative level triggered. If that bubble is not there, that is positive level triggered. Simple. Clear? Clear? So this is the thing. So this is the configuration. This is a master, JK, slave. This pen is not working properly. Slave is D. Clear? So now we'll see the timing diagram of this one, how the output will be generated. Okay. So if you see, then you will get the clarity of this one. First I will explain. See, let's assume J is 1, K is 1. Okay. This enable will be triggered when it will be low. Okay, when it will be low, means it will be 0 when it will trigger. This one will be triggered when it is 1. When it is 1. So now if my clock is like this, so this one will be triggered in these low positions. Okay. So that one will be triggered in these positions, right? Yes or no? Yes or no? So now my J is 1, K is 1. So what is my output? Q becomes, okay. So J is 1, K is 1. This enable is 0. What is my output? Based on the memory. Okay. If my memory QM, memory value is previously 1, the same value will be go to here, right? Same value will be go. Memory is 1. Okay, my J is 1, my K is 1. Same value will be go? No. Opposite toggling will happen, right? 0 value will be goes. This 0 will goes to D. This D will be take 0. D input is 0. What is the output of D flip-flop? D latch. Same. Why we take D as a slave? First tell me why we take D as a slave. See, this is a king. JK is a king. Okay, D is a slave. Okay, who's under work under the king. Whatever the instructions will be given by king, that should be followed by the slave. Whatever the data given by the king, data should be given to the as the output to the slave. If it will take same data, it will pass to output. So now how we are making this? Okay, how we are overcoming the raise around condition means in the latch, if you observe, okay, timing arc will be directly input to the output. Timing arc will be directly input to the output. These things will be there. In the flip-flop when you comes, okay, so the timing arc will not be direct. The timing arc will be from the input to clock enable pin, from the clock pin to output Q, timing hours will be there. Getting? So that's the reason raise around condition will not be there. The clock it will not be there, but it will be there in the latches. So now you should get one question here. So then this one also latch only. This one also have raise around condition, na? I'm using latch only, right? Something else I'm using. Then why you are not get this question? I only need to ask the question. I need to answer, huh? You need to ask, right? So this one, why it will not get means this whatever the levels we are giving, clock levels, that is not that sufficient, and keep on checking the outputs and generating the inputs. Even though if it is there, sometimes possible, but they will make like that. Okay, so this latch, when output is generated, it will go to the negative. Getting? It will go to the negative. If normal direct latch, if they will make, right? So how they will make direct latch means, okay, it can check the raise around conditions. Clear? But this master slave configuration, when they did, okay, you are avoiding that. Okay, that raise around output should be connected to input. You are avoiding that case, it will not be comes. Clear? So this is the master slave configuration. We'll see the timing diagram of this JK flip-flop master slave configuration. So then you will get one clarity. Clear? So now we'll see the timing diagram. JK flip-flop. JK flip-flop. So now let's take clock. Let's take clock. Clock. Okay. This is the clock signal. Clear? So you need to remember. So slave will be turned on at positive. Master will be turned on at negative. Okay, master. So if you for your remember, okay, this is a slave. Top I am writing slave. Slave will be turned on here. Master will be turned on at negative. Clear? So now I need to be take the inputs also, right? My J input, first it is 1. First it is 1. First it is 0 for suppose consider. After that becomes 1. It becomes 1. And K also, first it is 0. After that it becomes 1. After that it becomes 1. Because both cases it will cover. Separately J0, K0 if I will take, right? So then if both cases will not cover. That's the reason. So next QM memory. QM let's consider, okay? QM let's consider at starting it is sorry, Q. Don't consider Q. Don't consider QM. Consider like a Q. At starting, I'm considering Q is okay. So master is turn on here, right? Previous value is Q is 1. This is 1 value. Okay, 1. So now master is coming. When enable is 1, enable in this case, in this time only it will turn on. When negative level is come, it will check what is the J value. J value is 0. What is the K value? K value also 0. So both are 0. What it will do? Both are 0. What it will do? Both are 0 memory case. Yes or no? 0 0 case memory. Means whatever the previous one value is, the same value it will maintain up to here. Yes or no? Means it is memory state. So next, when come to the positive, it will be go to the off mode. Off mode means what? Latching, holding state. Means same thing will be continue to the next pulse. So now in this pulse, again master will be turned on. Master when turn on, what it will do? It will check, okay, what is my J, what is my K? J is 1, K is 1. Both are 1. So both are 1, what it will do? It will be toggle, means whatever the previous value, quite opposite it will generate. Previous value is 1, 1. So now what it will do? It will make to this one 0. This is 1, this is 1, this is 1. Then it makes 0. So now again what happens again? So in this condition it will goes to off state. Off state, whatever it is there, same holding state. Means it will be hold up to here. So now next what happens? Next master will be turned on. In this case it is 1, it is 1. Toggle. This one is 0. This one is 0. Now it will what it will do? It will make to 1. Toggle means 1 opposite. It will make to 1. Up to here it will be 1. After that what happens? After that it will go to off mode, means holding state. So no. Clear? This is the Q. Means so based on this J and K, so we draw this Q. This Q only input for D. Okay, this Q only input for D. So now based on the enable and D, I need to be generated the QD. Getting? So this is a JKQ. Input for D. So now DQ I need to be generated, right? Output of a D. So now DQ how we need to generate? Now slave will be turned on here. Okay. In this condition, what is my value? 1. 1. D means what it will do? Same thing it will pass, right? This one is 1. So now in this condition, what happens? Master will be turned on, slave will be off, right? Off, what happens in this condition? It will be off means whole state same it will be pass. So next is slave will be here turn on. In this condition, when it is turned on, what is the value here? 1. Same it will pass. Okay, same it will pass. So then master will be turned on. In this condition, slave will be 0. So then it will maintain same hold. Getting? So next what happened? Slave will be turned on. In this condition, slave turned on. What is the value? 0. So then it will switch to 0. It will switch to this 0. So next off mode means same thing it will maintain. So next slave will be turned on. In this condition, it is 1. So then it will switch to 1. So next condition it will be off, right? So it will maintain the hold. This is the Q for D. Getting? Timing diagram will be like this. So if someone will ask to be write the timing diagram, okay? So then you need to go like this and you need to write the timing diagram. Clear? So master and slave, this is negative and this is positive. This is a positive edge triggered flip-flop. If someone will ask negative edge triggered flip-flop, quite opposite. This will be master, this will be slave. Clear? So there you need to be make, okay, bubble instead of here, bubble you need to keep here. Getting? That's it, simple. Remain configuration is same. If someone asks, okay, with respect to gate representation, first to draw this diagram. So then inside this, okay, whatever the gates are there, 4 gates you will draw. So inside this, whatever the gates are there, you know how it will be. SR only. So one inverter it will comes. That you will draw. Both you will connect with these connections. Simple. Clear? So this is the JK flip-flop configuration, master slave configuration. Any questions, any doubts here? Any questions, any doubts here? J and K? output. See, this only, right? J and K. Yes or no? J and K. So J is 1. K also 1. These both inputs are 1. Now it is depends on other input which is based on the memory. Now my memory is 0, for suppose example. This will become 0. NAND gate, what is the single statement? Any one of the input is low, output will be high. No doubt this becomes 1. When this becomes 1, okay, this is Q bar is, this one Q is 0, Q bar will be 1. This is all or 3 are 1. What is the output? 0. 0, 1 given to this circuit. Okay, 0, 1, generally 0, 1 means, okay, SR latch, it will be reset. But this is a SR NAND based SR latch, it is quite opposite. Set. Set means what it will do? 0 becomes 1. Now what it will check? It will take this 1 will becomes here, 1, 1, 1, what it will generate? 0. Here Q bar will be, so Q bar will be 0, yes or no? Q is 1, Q bar will be 0. So 0 will be go, 0 means any one of the input is low, this is high, 1, 0 means what it will do? Reset. Then becomes 1. Getting quite opposite it will generate. So 0, 1, 0, 1, 0, 1, toggle mode it will comes. Clear? So like operation. So based on that, it will be generate the things. Clear? Any questions, any doubts here? Now, keep a heading. Asynchronous input of a flip-flops or latches. Asynchronous inputs of flip-flop and latches. Best example I will give for this, you will understand that. Inputs of flip-flop or latch. So if you are consider that is as a latch, that is a latch. If you are consider that is as a flip-flop, that is a flip-flop. Okay, I'm taking as a box. If suppose, okay, so if I am considering this is a JK enable, Q will be there, Q bar will be there, right? These are the inputs, as you know. Okay, so if suppose this is a latch, if flop means, so instead of here enable, they will call clock CLK. They will keep CLK or CP pin, they will keep like that. So now I will take one more example. Yes, R. Okay, CP pin. This is flip-flop. I am considering flip-flop Q bar. Clear? Q and Q bar. So now, you know only these are the JK enable RCP pin is a inputs. But there are two other inputs also will be there. That is one is set, one is reset or clear. This reset or clear also in the two types again. Okay, so positive reset will be there, negative reset will be there. This set and the reset or clear will be called the asynchronous inputs of a flip-flop or latch. Asynchronous, this is set S and clear, they will mention C or R. Okay, so asynchronous inputs of a flip-flop or latch they will call. Why they will call asynchronous inputs means, so this set or reset will not depends on the clock. So generally, whatever we explain here, the output is changing based on the clock. But when the reset will comes, whatever your clock, okay, it will not check, it will apply the reset directly. It will apply the reset directly. So that is the synchronous reset. Synchronous reset means when you are applying the reset, it will check the clock. According to the clock, it will be reset or it will take time to be reset. That is the synchronous. This is the asynchronous. What is the use of this reset, clear and set? What is the use? Where we will use? Simple example I will give. So everyone have a mobile. Have you download movies or not? You will watch movies or not? After watching movie, you will delete that movie or not? And again, you will download one more movie or not? Yes or no? So now, first when you are downloading the movie, in your mobile memory will have a lot of flip-flops and latches. Those all need to be set zeros one zeros one zeros one based on the color coding, based on the which format it is, HD format. These all things, flip-flops and latch based on those memory, it will be set all the values. Downloading means setting the data in the memory. Now, so the data is processing, right? Whatever we discuss here, the data is transferring, processing. When you are watching, scene by scene is changing, right? It is not same, right? The output will not be same. Scene by scene it is changing. Scene by scene, how it is changing? Data is changing. Data process is changing. That's why scene by scene is changing. The data processing will be depends on your clock. Getting the output is changing means the data processing is changing. 0, 1 combinations are changing. So then you are getting that. This is the processing. Whatever we discuss, timing diagram, these all things. The next thing is reset. After watching, you will delete, right? When you are deleting those all the flop, whatever flops, values need to become 0, right? That's only reset. That is the use. Clear? So easily will remember. Clear? So this is the use of set reset. JK means processing the data. JK values are zeros or ones. So based on that, it will process the data. Clear? So when you are open that and you are click on to be play, so then only this need to be process the data. Otherwise not required, right? Like that it is. Getting? So these are the two inputs which we need to discuss. And these are the inputs, okay? So you will see in the STA as well, STA, static timing analysis. So timing arcs you will see, okay? How the timing arc between J to E enable to Q, okay? Reset to enable, reset to Q, okay? How the timing arcs will be? What is this asynchronous inputs means? What are the timing checks we need to do, okay? These things you will see in the static timing analysis that I will introduce in end of this means next, no, I think next class I will discuss that, I think so. So then you will know, okay, okay, this is digital will be integrated with STA. You will understand that one. So now if this one is understand, so then we need to be discuss this flip-flop and latch differences. Understand, right? So this will be, this set and reset will be there for both latches as well as flip-flop. And this can be, this reset and clear can be, okay, negative also there, positive also there. Getting? Positive also there, negative also there, both will be there. Clear? So now next keep heading the differences between flip-flop and latch. Difference between flip-flop and latches. Flip-flop latches. First point. Flip-flops are made up of latches. Flip-flops are made up of latches. Latches are made up of logic gates. Logic gates. Latches are made up of logic gates. Clear? Flip-flops are edge triggered. Flip-flops are edge trigger. So next here, latches are level trigger. So it is made up of latches. So means two latches they will use. Okay, what is the speed? Speed will be less. Means it will be slow. Latches are slow. Flip-flops are fast. So here two latches they are using means power consumption. More power consumption. Here lesser power consumption. Next, fifth point. Raise around condition not present. Raise around condition not present. Here raise around condition will be present, right? Will be present. Raise around condition will be present. Sixth point. Flip-flop stores how many bits? Hmm? Latch stores? Then why we went to flip-flop? Both are store same bits, right? Then why we went to flip-flop? Why we need to use two latches? Hmm? To eliminate raise around condition, we went to flip-flop. Flip-flop and latch both will store single bit data. Note down. Flip-flop stores single bit. Latch also store single bit. Getting? Any questions, any doubts here? Do you know when humans are first time went to moon? So what is the chip they used? Okay, memory of that chip. Do you know that? What is the memory? Don't know. I think 4 MB something. Have you used in the mobile with that now? Refreshing time only, how much it will take? Just imagine. I think 4 MB or 400 MB, I'm not sure, but it is 4 related to 4 only. Okay. So that much from there to here, how much evaluation is happened in the digital world. Towards everything will be digital. Previously, advertisements will be banners, these all things will be there. Now, on big TV they will kept. So no. So previously everything will be written in the railway stations, also everything will be written on the boards. Now everything on the digital displays. So no. World is changing. Digital towards digital it is moving. So think you are in this position. Think about that. Clear? So these are the differences, these are the things. Understand? So go with these things. Okay, come up with the questions and doubts. So tomorrow is Friday, right? Saturday we'll discuss the doubt sections. Tomorrow I will introduce how the main, okay? So now the master slave configuration is one. So if you give, okay, this one to be edge triggered, here edge triggered if you are giving. So this is also on flip-flop. Getting it will convert as a flip-flop. Okay, this is a second thing. Two types. Flip-flops you can be, okay, represent in different ways. Third way is which is used in the VLSI design. Okay, so that how you will represent with the transmission gate which I explained in the CMOS transmission gates. With the transmission gate we will make the flip-flops. That is the third thing which we'll use in the VLSI designs. Okay, so why we will use also that I will tell you. So you need to be go with these all the things. Okay, what are the difference? And one more question. In the chip, which type of flip-flop we will use? They will ask in the VLSI chip, commonly which type of flip-flop they will use? JK, SR, D, T. Four options. Which one? Hmm? D. D. Why D? Why data flip-flop? Hmm? For data storage. Which flip-flop? D. T. T flip-flop. Always its output will change, right? JK. One more option is there. SR. D only. D, the flip-flop which will be used in the VLSI chips. Whatever the data will be processed with the combinational logic, the data need to store and transfer. Getting? The data need to store and transfer. So when I am saying this one, so why we need to use in our design flip-flop? Okay. So one greatest question which is asked in my interviews. See, I have a input. I have a different combination of cells. For simplification, I am taking buffers only. Okay, buffers. Different combination of cells is there, and I am generating the output. Each buffer will take the delay of 10 ns RPS. So how many? These are 10, 10, 10, 10, 10. So when input to output, generation output, okay. So how much time it will take? Input to output 60 ns. 60 ns it will take. First input I am giving, after 60 ns output will be comes. Next output when it will comes, first output will comes 60 ns. Second output when it will comes, second output after 60 ns only I can give, right? Then 120 ns. Third output 180, no doubt. Now the same circuit, why I am trying inverters? The same circuit, this is not inverter. One flop I added. So now, this flop also will be 10 PS, 10 ns. So now what is the first output it will get? First output when it will get 60.
Okay, 40.
Total first output when it will get 70. Yes or no? 70 ns. Next output when it will get? Next output when it will get? This will be connected to clock. Next output when it will get? 100. How 100? It should be 140, right? How 100? See, now I am using in middle one memory element. Getting? First, I given the data 0. It will pass through this buffer, 30 PS, then it will reach and it will store here 0. After that, what happened? Next clock pulse, this will be send the data to this. It will pass to this, and then it will go to the output. 70 PS it will take. So now when next clock pulse is coming, here also data will again, one more data will comes, right? One more data will comes. That data, one more data will comes and store one now stored. So when next clock pulse will comes, immediately this output will comes, right? How much time it will take? Next output will come set immediately. Second output will come set immediately. At 100 ns. Third output will comes 110. So if two buffers, if I will give two storing element, so the speed of the output will be increased. Maybe starting first input may take more time, but after that speed will be very easily, okay, you can get the output. Clear? That's the reason we will use the memory elements. Directly only combination I can use, right? These are the question, out of the box questions only they will ask. It's not like, okay, explain JK flip-flop. Okay, what is raise around condition? No one will ask. Nowadays, no one will ask these things.